Tony. Okay, question number 1 in the midterm I sent you. Starts the question with the diameter of golf balls must be standard. The diameter is approximately normal, mean, and since they say approximately normal, we could say mu in this case. So mean is mu, 172 inches, with a standard deviation, sigma. So again, since they mention approximately normal, so mean and standard deviation would be mu and sigma. And sigma in this case, 0.3 inches. Now, according to the club, the diameter must not be below 168. For particular manufacturer, golf balls below 168 will be scrapped. For this manufacturer, profit drops dramatically if the percentage of scrap exceeds 10%. Question: what's the probability that a selected golf ball, one ball, will have a diameter less than 168? So we're talking about what's called probability of a single unit. One ball, and it's less than 168. And if this probability is more than 10%, then it will be scrapped. Okay. Single unit, so we start with drawing the curve. Middle point is mu, and according to the question, 172 is always at the Z0. The middle is always at the Z0. 168 would be a number here, and less would be this part of the curve. So the formula for single unit is x mu over sigma. So it's 168 minus 172 and over 0.3. If you do this in the calculator, it will give you negative 133. So now I know that in terms of z, x less than this would be z less than negative 133. And then you go and find this from the table. I told you the 3 cases, I'll write them again here. Case 1, if you have probability z more, it would be 1 minus table. Case 2, if you have z less than a number, it would be table right away. In case 3, if you have between 2 numbers, a large and a small, you get the large from the table minus the small from the table. So you go to your z table. You can use the ones he gives you in the course, or you can use, I'll send you one that's very good, that has all the different numbers. But again, if you want to look it up, the number from the table would be 0.0. So basically what you do, you go to the negative side, you look for the 2 digits. Negative 13, with the second decimal place 03. So negative 1303, and you'll see a number here. That's in the negative table. And the number, when you look it up, it would be 0918. So the answer would be 0918. So the probability of ball being scrapped is 9.18%, so less than 10%. So it's not like what they think that it exceeds 10%. So the probability of being, the probability of a ball being less than the probability of a ball with a diameter being less than 168 inches is 9.18. That's less than 10%. Don't need to scrap. So it's not going to be scrapped because they tell you if the probability is more than 10%, that's the only time that it will be scrapped. Okay, so we did the A. The B question, between what two values symmetrically distributed about the mean will 98% of the golf ball actually fall? Okay, so to do this, the trick here is to first draw the curve, and after you draw the curve, middle point is mu, and in this case 172, at the z line 0. They tell you it's 98%, and they tell you that it's symmetrical. So if it's 98 and symmetrical, so you have to be like this, so it's 98% around the middle, leaving you with this portion 1% and this portion here 1%. So there is a number here A, and there is a number here B, where between A and B you got the 98% symmetrical. So in order to do this, you know that the equation is x minus mu sigma, and A and B would be x values. So since we know that we're looking for x values, we can use this formula that's generated from this, which is z times sigma plus mu. So we use this formula first for finding A, and then we use it for finding B. Okay, so to do it for A, what we need to do is we need to find what z is at 0.1. So you always look at the percentage from the left. To get to A, you need to cover 0.1. You go to the z table, so you'll see the two pages. This is the positive, this is the negative. And when your percentage is less than 50%, you'll be looking at the negative. So you go to the z table. I'll send you the one I use. You can use the one from the course. It's the same. So you go to the table and you look inside for the closest possible to 0.1. You'll see that in the table there is an a 0, like closest possible to 0.9. There is a 0.099. So there is a 0.099. That's very close to 0.1. You can't see anything closer. And if you read the z table of the z number, it's minus 233. So this is x equals minus 233. Your sigma is 0.3. Your mu is 172. So you put all in the calculator, negative 233.03, 172, and that would be 16501 inches. To get the B number using the same equation, which is x equals z sigma plus mu. Now, as I told you in the previous one, to see the number, you have to read the percentage from the left. So from the left to get to B. From the left to get to B, you'll be covering 99%. You'll be covering the 01 and the 98. So you need to look for Z at 99. And since this is more than 50, we go here. So we go to the positive, and we look for closest possible to 9. 9. If you go, you'll see that there is a 9901. You can't see anything, like this is the closest possible. 9901. So, and if you read the number, it will be 233, and it's supposed to be the same number positive because they're symmetric. So as a way to double check your work, then you're doing it right. Times the 03 plus 172. So you go back to the calculator, and that will give you 17899. So you can say that 98% of balls will fall symmetrically between, and you put the two numbers, they will fall between 16501 inches and 17899 inches. Good? Before I get to the B question, the C question, sorry. The other types of this symmetry question, they could tell you, get me the diameter that's in the top 10%. So you would draw the curve. Mu would be 172, Z0. Top 10%, so it must be here. We're above it, 10%. So to get to it, you'll be covering 90%. So to get this number, you need to know what Z is at 90%. And you do it the same way. So you go to the positive table, you look inside for the closest to 90%. And I believe that if you look it up, the closest to 90% would be 8997. So you'll see that it's 8997. And in this case, you'll use 1.27. Some people use 1.28. It doesn't matter. They're all good. They could say, find the diameter, bottom 5%. Then you go, well, this is the bottom. So to get to it, it's 5%. So I need to look for the 5%. So if it's the top, you need to switch because you always read it from the left. But if it's already in the bottom, it's already in the left, so you don't need to do it. So you go to the negative table, you look for the closest to 05, and you'll end up with something like 164, 165, or 1645. These numbers are the closest, but of course negative, because all the numbers we get from this would be negative. What other types? Instead of top 5 or top 10, they could tell you, get me the number that's in the 95% percentile. You see this word, 95 percentile. Means basically that you need the number that covers 95%. So this would be Z as the closest to 95. You go here and you look for the closest to 95. Good? Okay, so this is it for B. We go to the question C now. Question C. A random sample of 20 golf balls. What proportion of the sample between 173? It's proportion, they mean what percentage or what's the probability, but it's probability of sample mean. Okay, I'll take you back to the question A. Question A, if you read the third line, what's the probability of a golf ball? When it's probability single or probability all. So if they say, what's the probability selected golf ball, or even if they say, what's the probability that golf balls, if they talk about all, in either case, you use X mu sigma. So when they talk about probability single or all, we use this. But this question is asking for a probability sample mean. Probability sample mean, we use X bar mu sigma over root n. So the question is, your mean, what's the probability, what proportion of sample means between the two numbers, and they give you the two numbers 173, 170. So that's case 3, large and small. So you start with drawing the curve. Middle point is still mu. It's 172, Z0, 173, 170, and between them. We use the equation of X bar mu sigma square root of n. Use it for a 170 first. 172, 0.3 square root of 20. So we do this 1.7 minus 172.03 square root of 20. And this will give you minus 298. I'll use it for this number. And that gives me 149. So the large is 149, the small is minus 298. So you go to the Z table, you go to 149 and see what the number is. According to the table, 149.9319. So the large, 9319. Now we look for the small, minus 2 with a 98, minus 298 would be 0014. And that's 9305, about 9305%. And you put the answer in a sentence. So you basically say the proportion of sample means between the two numbers is, and whatever that is, 9305. Good? Okay, so we go to the next question, question number 2. They tell you a recent CBC interview with students at Dalhousie stated that 10% of the first year failed as a direct result of too much time spent online with social media. A group of St. Mary decided to see if this might be the case at the university. They brought 48 first-year students, Basir interviewed, and the number of hours they spent on social media. So all of these numbers given in the table are for number of hours. So, and if you look at the numbers given, they're all in order. So like the first number is 14, then 14, then 14. So they go in order this way. They keep going up till we reach a last number, 34. And if you count, you'll see that there are 12 numbers in each line. So 12, 12, 12, 12, that would be the 48. They also give you the sum of x, the sum of times, 1149. And they also give you the sum of x squared, 28917. What type or level of measurement this data represents and why? Anytime the numbers given have the unit measurement, like hours, inches, meters, liters, whatever, anytime they have a unit measurement, we say this type of numbers represent ratio, since data is time measured in hours. So anytime you have something that's measured in hours or has a unit measurement, right away it's a ratio. What's the median? Okay, to do the median, I'm actually going to do two things. I'm going to do the median, and I'll do the mean too. The mean, you basically take the sum of x over n. You have the sum, it's 1149, and we know it's 48 numbers. So 1149 over 48 gives you 239375 hours. That's your mean. The median is the number that's in position n plus 1 over 2. This is called the rank or the position of the number. We know altogether there are 48 numbers. You add 1, divide by 2. So you add 1, you divide by 2. We need the number that's in position 24.5. Since we know that there are 12 numbers in each line and they're in order, the number that's in position 24 would be the last number in the second row, which is 25. So that's the number that's in the 24th position. But what I need is, I need the number that's in the 24th position, and I need the number that's in the, I need the number that's in the 25 position. So the number in the 24th position has a value 25, and the number that's in the 25th position has a number 26. So once I have the 24th and 25th, I average them. So what I need to do is I take the number in the 25 position, add it to the number in the 24th position, and divide it by 2. So I need the 25 plus 26 over 2, that's 25.5 hours. So now I know the median is 25.5 hours. So again, when you look for a median, if it's something 0.5, you need the 24th, you need the 25th number and you average them. You average their values. Okay. The next question, C. Find the standard deviation. Now, the formula for the standard deviation is, you have to do it in steps. The first step, you do something called SSX, and that's total variations. That's the sum of x squared minus the sum of x squared over n. Sum of x squared is given, 28917. Sum of x is given, and there are 48 numbers. This number here is 141,28125. Step 2, you find the variance, where it's, you take your SSX you just did, you divide it by n minus 1. So you take the 141,28125 and you divide it by 48 minus 1, so you divide it by 47. And that gives you a variance of 30.0598. Then standard deviation, which what the question is asking for, S, would be the square root of variance. So you square root this number, and that gives you your standard deviation. I'll add it here. The standard deviation is 54827. That's your standard deviation, and it would have the same unit measurement, hours. So we found the standard deviation by following the steps. Total variations, variance, and then you square root it to find standard deviation. Determine IQR. Now, IQR, or also called the interquartile range, is Q3 minus Q1. But here there is a little bit of a problem, and I'll tell you what it is. First of all, we need to find Q1. Melissa Saagh has two different ways of finding Q1 and Q3. Sometimes she uses this way, sometimes she uses the other way. So I'll show you both ways. They're very close to each other. But again, I want you to double check from notes, from lectures, to see which one she's using this semester. Q1, she usually goes and says it's a number that's in position n over 4. There are 48 numbers over 4. So you need the number that's in position 12. And we know that at the end of the first line, that number is 20 hours. And for Q3, she uses 3n over 4. So that would be the number in position 36. And that would be the end of the third line. and that would be 28 hours. So Q1 is 20 hours, Q3 is 28 hours. Now, in other semesters, I'm really leaning toward this more, but again, she could be using the other way. The other ways that she uses sometimes in some semesters is instead of going n over 4, she goes n plus 1 over 4. So there are 48 numbers, you add 1, divide by 4. So 48 plus 1 over 4 gives you the number that's 12.25. And the way to do this is you find the 12th number plus 25% of the difference between this and the one that's after. So you go with the 12th number and 25% of the difference between that number and the one that's after. So that would be the 12th number 20, 25, and the difference between 20 and 20, it would eventually be the same number 20, because 20 minus 20 is 0. So your Q1 is still 20 in this case. Now to do Q3, instead of 3n over 4, it becomes 3n plus 1 in brackets plus 4. So it would be 348 plus 1 over 4. That would be the number that's in the 36.75 position. And similar to the one we did, you take the 36 number, you add 75% of the number and the one that comes after. The 36 is 28, 75% of 28, and the one that's after is also 28, so it ends up with 28. So you'll end up, because of the numbers being close, you will end up with numbers the same in either way, either approach. So, but it could be different if the numbers are different. So I want you to double check her notes. See if she's doing it this way, the n plus 1, or just n over 4. So is it n over 4 or n plus 1 over 4? Is it 3n over 4 or 3n plus 1 over 4? So double check to make sure that you do it the way she's doing it this semester. Okay, we found Q1, Q3, and they happen to be the same in either approach. Your IQR is the difference between 28, 20. So your answer is 8. Your IQR is 8. Okay, so we did this question. We go to the E question. Now, use the 5-number summary to describe the shape of the data. So, to describe the shape of the data, so we do the 5-number summary first. That's part E. The 5-number summary would be the minimum value, Q1, the median, Q3, and the max. your minimum, the smallest number in the list is 14. Your Q1, we did it, it's 20. Your median, we did it, and it's 25.5. We did Q3, and it's 28. And the max would be 34. Now, to use this and discuss the shape, and you know, the shapes are either left skewed, right skewed, or symmetric. I'll tell you a hint. Remember when we did the mean and the median? Anytime mean and less than median, you have left skewed. When the mean is more than median, you'll have right skewed. And when they equal each other, you have symmetrical. You have symmetry. And according to the calculation, mean is 23.9, median 25, so mean is less. We know we're left skewed. This should match, not necessarily all the time. Sometimes it doesn't match. But we're hoping that this matches. Now the way to analyze this, find the difference between Q1 and median. The difference between them, this minus this, is 5.5. You also find the difference here between median and Q3, and the difference between these two numbers is 2.5. Which one is longer? This one is longer. This one is to the left, so you're left skewed. Sometimes they also take the difference between the minimum and median. The difference here is 11 and a 5, and they take the difference between median and max, and that's 8.5. And you see that also the left is longer, so left skewed. But the main thing is Q1 to median, Q3. We don't care much about the minimum and the maximum because there could be screen points. So whatever distance is longer, we consider that's the skewing part. Good? Now, also could ask in this question, are there any upper or lower outliers? So let's start with lower outliers. Are there any lower outliers? To do this, we need to do what's called the LF, which is lower fence. You take Q1 minus 1.5 of your RQR. That's standard. That's a rule. Q1 minus 1.5 IQR. Remember, Q1 is 20. And IQR, we found this to be 8. So 20 minus 1.58, that gives you 8. If any of the 48 numbers less than 8, we have lower outliers. None of the numbers less than 8. No lower outliers. Now we test the upper outliers. So we need the upper fence. So the upper fence would be Q3, 1.5 of IQR. Q3 is 28, 1.5 of 8, so 28 of 8, that gives you 42. That gives you 40. Do we have any numbers more than 40? So for lower outliers, you must be less than the lower fence to be lower outlier. For upper outliers, you need to be more than the upper fence. None of the numbers are more, none of the numbers more than 40, no upper outliers. Okay, I'm gonna stop. This would be the first part. The second part will continue with this midterm.